Okay, so this is the second question he gave in the lecture. So evaluate this, where B is a unit ball. So the first thing we know is that we're dealing with ball, so our theta value is going to be just that, just right around the circle. We also need to remember, now this is confusing, that our phi value can exist only between there. And you should really think of your phi value as going from the highest point on the z-axis to the lowest point. So think of it just going highest to lowest point. So in this case, just pi. So pi 0, and lastly, d phi. Our rho value is just our radius, and they've told us it's a unit ball, so that means our radius is 0. Next thing we have to realize is x squared plus y squared plus z squared is the same thing as p squared, and this is 3 to the squared. And then we can do a quick calculation and realize that this is equal to p6 on 2, which is p on 3. Yes. d rho. d rho. And you might think, hey, I'm done. But if you wrote that, you would be wrong. They would mark you down, and they might shoot you, let's be honest. So it's going to be e to the p3 p squared sine of theta. I keep saying p, rho, d rho d theta d theta d phi. My goodness gracious me. So now we integrate. How do you integrate this, you say? Well, you have to let u equal, actually, let's write this over here. Let u equal rho cubed, so therefore du d rho equals 3 rho squared, so therefore d rho equals du 3p squared. We can now put this into our original. You can look at this and you say, hey, we have no thetas here, so I can immediately put theta on the outside. Pi 0 1 0 e to the u p squared du 3p squared sine theta d phi, sine phi d phi, and we got rid of our theta value. Then you go, hey, look, p squared cancel out. And we have this 1/3, so we can take this 1/3 to the front. Pi 0 1 0. Now we're left with e to the u du sine phi d phi. What is the integral of e to the u? What is it? It's e to the u. And you can sub back in our u value, which was p rho cubed. My goodness. 1 0 sine phi d phi. Then that's going to become, e to the 1 minus e to the 0. Now we have to integrate. So this is e minus minus 1. The integral of sine is negative cos of phi between pi and 0 d phi. Idiot. You don't write that again. And then this will be 2 pi on 3 e to the negative 1 negative cos pi minus plus cos of 0, which is going to equal 2 pi on 3 e to negative 1. This will equal plus 1, which is the same thing as 1 plus 1. So you're going to get a 2 out the front. Sorry, 4 pi on 3 e to the negative 1. And that's the answer he got in his lecture notes. Killing it.